Given triangle RPQ, the length of the altitude RS is 24 inches. Find the perimeter of triangle RPQ.
So we know RS is 24, and it wants the perimeter of basically the big triangle, right? So how many sides do I need to figure out, or how many sides do I need to compute? This is 1. That's 2. That's 3 from this triangle, and then a 4th one. I'm gonna call that N. Now, which order you find these really doesn't matter, but let's go ahead and focus on angle 33. If I wanna find X, and given the opposite, which trig function are we going to use? Sin or sine? So we have sine of the angle 33 is equal to my opposite 24 over the X.
What?
If you wrote Y, that's fine. Maybe my reference has Y, but I just kind of start from the beginning. What can I do with the variable on the bottom to the other side?
It's mathematical.
We can swap. So we get 24 over sine of 33. Let's type that in. 24 over sine of 33. Hopefully it's already in degree mode, and yes. And this number should be bigger than 24 because that's my hypotenuse, right? So let's go ahead and round this. So my X is about 4.066. Okay, any questions on that one? Good? Okay, let's find Z. To find Z, and I do not want to use this rounded number. I do want to use 24 because it's clean number, and I do want to use the adjacent. So which trig function do we have to use?
Cosine.
Tangent. We have tangent of 33 is equal to my opposite 24 over the Z. Again, I have my variable in my denominator, so what can I do? Switch. So we have Z is equal to 24 over tangent of 33. Let's type that in. What's our decimal value? 30.
32.337.
Oh, I get 36.957. Boom. Everyone good with that?
Oh, I wrote 24
Okay.
for some reason.
That's okay. Now let's go ahead and find Y. To find the Y, and I'm looking at it from 52, which trig function should we use to find Y? I know my opposite. I need my hypotenuse, so we need to use sine. So we have sine of 52 is equal to my opposite 24 over the Y. Can we swap them again? Thank you. Okay. So we have Y is equal to 24 over sine of 52. Type that in. It's got to be less or greater than 24 since it's our hypotenuse. 30 point how many?
456.
4, 5, 6. And then our last piece, the N. Which trig function are we going to use for the N? So we have tangent of 52 is equal to our opposite 24 over the N. Swap again. And let's type. $18 point something. 751. Now, ideally, we should not round as we go, meaning you should put in the original long decimal if you can find it and select it. But for me, I think I'm just going to type in what I have from 3 decimal places, meaning I may not be as accurate as I should be. And our perimeter is somewhere in the 130. 130 point. Are y'all waiting on one person to type everything in?
No, I was doing the math.
23.
0.23, thank you.
Yeah, Cooper's just measuring.
I am recording. Let's go on to number 14. Oh, 14's a good one.
Thank you.
Yeah. Okay, are we good to move to the next page on this?
Yes.
Okay? What kind of figures are given to you on number 14?
Polygons.
Polygons, and specifically it is a regular polygon, okay? So let's start with our total first. It says to find the total interior and each interior. Once I find the total, all I need to do is divide it by that many angles. Now we know, in a triangle, our total angle is 180. Is everyone okay with that?
Yes.
And because they're all equiangular, each of them must be 60 degrees. What about in a quadrilateral? Our total angle measurement must be 360. So therefore, if it's regular, each of them must be 90. Now I'm going to get to the formula then. So for the pentagon, our total is going to be found by 180 times n minus 2. In our case, our n is 5 minus 2. So if you put in the calculator 3 times 180, our total has to be 540. What do I divide 540 by to find each? 5. And when you do, what do we get? 108. Everyone good with that? For the total of the hexagon, same formula applies. 180 times 6 minus 2.
Wait, why is this? Oh,
Because hexagon is a 6-sided figure, right?
yeah.
720 it is. So if I take 720 and divide it by 6, they're each going to be 120.
I just know that for hexagons. specifically.
I know it mainly because hexagons have 6 equilateral triangles, and 2 of those angles become 1 angle in that interior.
Oh god, is that a heptagon?
That
Uh-huh.
has 8 sides.
And then we have, it's a heptagon, it's not
That
septagon.
is gross.
So we have, but to me, like, it's septagon sounds like it's right, because 7, but no, it's heptagon. So it's 180 times 7 minus 2, and that's going to be 900, correct? So each of them, when you divide it by 7, it's not going to be clean. So let's make it into 3 decimal places. 128 point, how many?
571.
571.